Hi friends, welcome to Civil Engineering Choice YouTube channel. I have already uploaded 4 videos on the simple stress and strain, and this topic is related to strength of material. So we have started that series already. I have discussed in last video. So these are the topics on which I am uploading the videos, okay, and these topics are related to only the numericals, okay. So on general numerical on elongation and stresses I have uploaded videos, and now we are discussing this second type, that is elongation of uniform cross section bars with the intermediate axial load. So as I discussed in last video, we are dividing these numericals in two part, okay, videos on the basis of this type in two part, that is 4.1 and 4.2. So 4.1 already I have uploaded. Now this is a 4.2, and these are the 3, 4, 5 and 6. These are the upcoming videos on which I will discuss some types of numerical. Okay, so let's start with the numericals. See, this is the syllabus that I am covering in the first unit, that is stress and strain. So these are the total theoretical part. Already I have discussed in last video. Okay, and then we have started the numerical. These are the types of numerical on simple stress and strain. I am covering it fast because already I have discussed in the some previous videos. Please go through that previous videos and see all the numericals and basic points that are required for the numerical. These are the formulas we require to calculate the elongation and stresses of any section. I have discussed it in last video. This is the important point to calculate the elongation of such type of force system, means intermediate force system or intermediate axial loads are acting in the uniform cross section. So for that, just calculate the total length. Okay, we require change in length or the total length of AB section, length of BC section and length of CD section, discussed in previous videos. Okay. For solving such type numerical, these are the important points that again that I have already discussed in last video. Just we will take some short revision while calculating individual force on the individual section. Okay, let's say suppose this is our section. Okay, total section, and we are considering suppose A, B, C, and D. So A to D is the total uniform cross section, and if we want to calculate the axial load on each section, let's say suppose AB, BC and CD, so we need to use some sign convention for the calculation. So for that sign conventions, initially we are considering left force negative and right force positive. Okay, and after the calculation of individual forces in each section, after that, we will consider compressive force as a negative and tensile force of the force as a positive for the calculation of total elongation. Okay. So already we have discussed in previous video. Just go through that. These are some numericals we have discussed in previous video. So I will give the link of that video in the description box. Okay. So link is available in description box. Just go through that and see that videos. Okay. Up to third numerical we have covered in the last video, and we will start with the next fourth video. Today we will discuss only two numericals related to this topic, and in next video we will start with the third type of numerical. So fourth numerical is what? A square bar 5 centimeter by 5 centimeter is subjected to an axial forces as a different location as shown in diagram. Find the force P and the elongation of a section bar. Take E is equals to 200 gigapascal. So now here we need to calculate the force P and the elongation of the section bar. Force P, where is the force P? This force we need to calculate. So what is the difference between this numerical and the previous numerical that I have uploaded on the last video? So in the last numerical or in the previous numerical, all the forces are given to us, and on the basis of that forces we need to calculate total elongation. But here this P force is not given. Okay, so first we need to calculate that P force and then find the elongation of given cross section. So that is the main difference between this numerical and the previous numerical. So how we can calculate this? Okay, so first write down given data. When every time, just remember, while starting the numerical, first you need to start with the given data. Just write down the given data. So A is 5 centimeter by 5 centimeter. Okay, means area 5 centimeter, 5 centimeter dimensions are given. So area is 50. Convert it in mm because stress is in Newton per mm square. Elongations we are calculating in mm. Then our E is given in kilonewton per mm square. That's why convert your all the dimensions in mm and kilonewton, like that. So centimeter, 1 centimeter, we know 1 centimeter equals to 10 mm. So 50 mm, 50 mm. So area is 2500 mm square. Okay. E, modulus of elasticity is given, that is 200 gigapascal, 200 kilonewton per mm square. Distances are also given, means length of AB, length of BC and length of CD subsection. 60, 100 and 100 centimeter converted in mm, that is 600, 1000 and 1000 mm. So that we will convert in the numerical uh, after applying the formula, or you can convert here also, no problem. 60 centimeter is equals to 600 mm, like that. Okay, you can write here also, no problem. Okay, now for the calculation of this P force, just apply summation fx is equals to 0. Okay, why we are applying summation fx is equals to 0? Because all the axial forces are horizontally. Okay, and generally we are considering horizontal force, horizontal axis as a x-axis and vertical axis as a y-axis. Correct. So all forces are horizontal, so it is parallel to x-axis. That's why we are applying summation fx equals to 0. Let's say suppose if in the numerical they have given this diagram, maybe if they given this diagram vertically, okay, vertically, so in that case we will apply summation fy equals to 0, because all forces are vertical and we are considering vertical y-axis as a vertical, so it's parallel to y-axis. In that case we can use summation fy equals to 0. But now for this numerical all forces are horizontal, so we will going to use summation fx equals to 0. So summation fx, we know the general consideration is left force negative, right force positive. So 50 kilonewton towards left negative, 90 kilonewton towards right positive, 20 kilonewton towards left negative, and P force again towards left negative. Okay, so minus 50 plus 90 plus 20, sorry, minus 20 and minus P, so we will get P equals to 20 kilonewton. Okay, so answer for P is 20 kilonewton. Now our first question is solved over here, that is find force P. Now here we get the value of P. Another thing, next we require the elongation of section. So again same rule, for the total elongation what we need to do? We need to calculate the elongation of each section. So already we have discussed that formula, that is elongation of first section plus elongation of second section plus elongation of third section. Okay, means first section AB, second section PC and third section CD likewise. Okay, so for the calculation of individual forces in each section, what we do? We consider the calculation from left or right. Okay, we will start our calculation from left end or right end. But here A and D both ends, means left and right, both ends are free. So we can start our calculation from any direction or from any side. But we are keeping one practice, or we are considering one rule for every numerical, that is for free end we are always starting calculation from left side, and if one end is fixed and another end is free, in that case we are starting our calculation from the free end. Okay, so now here both ends are free, so we will start our calculation from A point. So from A point, our first section is AB, so just take a XX section at this near to B point and focus on the left side. Okay, so on left only one force is there, that is 50 kilonewton, and the direction of that force is towards left, so it will be negative. So minus 50 kilonewton means that force 50 kilonewton force is acting towards the left at A point for individual section of AB. Okay, so here for individual section AB or the first section, the force at A is towards left 50 kilonewton. So on the basis of that force, just consider the 50 kilonewton force just opposite to the 50 kilonewton force at A point. So here we have considered this force is towards left, so here towards right. Likewise, similarly, take another section YY and again focus on left side. So on left side two forces are there, 50 kilonewton and 90 kilonewton. 50 towards left negative and 90 towards right positive. So minus 50 plus 90, that is plus 40 kilonewton. Plus 40 kilonewton means that 40 kilonewton force is acting towards right at B point for second section. So for that second section, 40 kilonewton towards right means that force is going towards the body. So just consider opposite at C point, it's again towards the body. So this direction is right side and this direction is left side, 40 40. Okay, then similarly for section third, consider ZZ section and the focus on left side. Now on that ZZ section, on the left of that particular ZZ section, three forces are there, 50, 90 and 20. 50 towards left negative, 90 towards right positive and 20 towards left negative. So total answer is in positive, that is 20 kilonewton. Again 20 kilonewton means towards right. Okay, so this is the right force. So on the basis of that individual forces, we will decide the sign of final force or the final force of individual section. So P1 is tensile, consider positive. P2 compressive, consider negative, and P3 again compressive, consider negative force. Okay, now this is L1, L2, L3 means length of first section, length of second section and length of third section, and just calculate the total elongation. The total elongation formula, delta L1 plus delta L2 plus delta L3. Just put all the values, P1 L1 by A E1 plus P2 L2 by A E2 plus P3 L3 by A E3. Put all the values where P1 is 50 kilonewton, L1 is 600 mm, then area is 2500, we have calculated in the given data, and the modulus of elasticity is same for all the section, 200. Okay, so just solve these all ratios, we will get total elongation is 0.06 minus 0.08 means 0.06 for first, 0.08 minus 0.08 it's for second. Okay, and next one, and third one is minus 0.04. So the total answer is minus 0.04. Total elongation of this section is in minus, it means the rod is contract. The rod is contract by 0.0 mm. Okay, this unit should be in mm. Why mm? Because we have considered length is in mm. Okay, so hope you have get the numerical. Okay, understand this numerical. If you are not understand, please write your question in the comment. Then next, fifth numerical, A steel bar of uniform cross-section area 500 mm square is subjected and loaded as shown in diagram. Determine the force P to be applied at B so that the lower end D does not move vertically. Take E is equals to 200 gigapascal for steel. See, now in this numerical, the section is given vertical, the force system is given to us, one end is fixed and another end is free, okay, but two conditions are given over here. First condition is determine the force P to be applied at B. So whatever force is applied at B point, that we need to calculate first. And the second condition is given over here, that is lower end D does not move vertically. Whatever lower end is given over here, that lower end will does not move vertically. Okay, generally what happen if we consider this section and any forces is acting on that particular rod, so may that rod will move up or move down due to the intermediate forces acting on that rod. But condition is what condition is the lower end D does not move vertically. So we can consider that moment of D point is 0. There will be no any moment, so it will be fixed. And another condition, bar is vertical but it's free at lower end and fixed at upper end. So we should start our calculation from the free end, means from the bottom. So as per our rule, first write down area of the section or given data generally. Steel bar of uniform cross section area 500 mm square. Okay. Then E modulus of elasticity is given, that is 200 gigapascal, and this is a steel rod. Okay, for steel rod. So 200 gigapascal, 1 gigapascal equals to 200 kilonewton per mm square. The condition, as per the condition, just write down what will happen in the bar. So condition is what? D point does not move vertically downward or the vertically upward or downward. We can say any direction. Okay, it's depend on the final elongation. It means the total elongation bar is 0, because see, if we consider this point or the movement of this point is 0, maybe C point and B point will move down and up if we calculate individual elongation or the individual section elongation, means elongation of AB, elongation of BC or elongation of CD. Okay, so maybe B and C point will move vertically up or down, but D point is 0. If D point is 0, so whatever total elongation is there of that particular bar, that total elongation is same. Sorry, total elongation is 0, means the total length will be same. That length will not going to change. So 500, 400, 300. Okay. So 900. So total length is 1200 mm is as it is. So bar will not elongate. That's why the elongation or the total elongation is 0. It means delta L is equals to 0. Okay, and for that section generally we use delta L, means total change in length is equals to change in length of first section plus change in length of second section plus change in length of third section. Okay, but now your total change in length is 0, so we can consider this equation as 0 equals to delta L1 plus delta L2 plus delta L3. Okay, so where delta L1 is what? It is the elongation of first section. So for that we can write P1 L1 by A E1 plus P2 L2 by A E2 plus P3 L3 by A3. We can write like this also. Just take A and E as a common if modulus of elasticity is same. So we can consider A and E as a column common, and right, P1 plus L1 plus P2 L2 plus P3 L3 is equals to 0. Like that also you can modify this equation to minimize the calculation. Okay, where E1 E2 E3 same, so we can consider as a E. So P1 L1 plus P2 L2 plus P3 L3 equals to 0. If you take that AE as a common, so what will happen over here? So just take as we discuss now, AE is common. So in bracket P1 L1 plus P2 L2 plus P3 L3 is equals to 0. So that AE, convert that AE towards the or move that AE on right side, so it will be 0. 0 into A is 0. So remaining is P1 L1 plus P2 L2 plus P3 L3 is equals to 0. So this is our equation, final equation, by putting condition for the total elongation and AE. Okay. Now after that, just apply our general rule, okay, and calculate it. So deflection downward. So downward force positive for reference only. Okay. So generally what happen in such case, the deflection, possibility of deflection of that rod is downward. Possibility of deflection, condition is given over here, deflection is not there, means change in length is 0. But if any elongations will occur in that rod, so that will be downward, because top point is 0. So top point is fixed, that's why the movement at up is 0. So maybe it will deflect downward, that's why we are considering downward deflection is positive, means downward force is positive. Okay, so for such type of numerical, we are considering sign convention as downward force as a positive to calculate the individual forces in each section. So again take section XX. Now we are starting our calculation from bottom to top, correct, from bottom to top. So at bottom of XX section, we have only one force, that is 30 kilonewton, and the direction of that force is downward, so it's positive. So for individual force, consider at D 30 kilonewton downward, just opposite to this upward 30 kilonewton, magnitude with same, magnitude is same. Again take section YY, okay, YY section. Now after that, focus on down part. On down part, two forces are there, that is 30 and 10 kilonewton. Okay, 30 downward positive, 10 upward negative. So plus 20 kilonewton, 20 kilonewton positive. So at C point, the 20 kilonewton force is at downward, so just opposite to that, upward force 20 kilonewton upward force at B point. And then last section, consider section ZZ. Again focus on downward. Three forces are there, that is 30, 10 and P. So 30 downward, 10 upward and P upward. So 30 minus 10 minus P is equals to 20 minus P, and the 20 minus P, initially we are considering that force is downward. See, here we have not applied the summation Fy is equals to 0, summation Fy is equals to 0 to calculate that P force, correct? So just we have discussed in last numerical, for the calculation of any unknown individual unknown axial force, just apply summation Fx is equals to 0 if all forces are horizontal, and apply summation Fy equals to 0 if all forces are vertical. But now here we have not applied summation Fy equals to 0 to calculate that P force, because our A point is fixed, and due to that fixity, it may be having support reaction. Okay, it having some support reaction, vertical support reaction and horizontal support reaction. So that support reactions are also unknown. So to calculate any unknown force in the section, we can apply summation Fx or summation Fy equals to 0 if both end are free. Just keep this point in mind. Okay. So just for third section 20 minus p downward at B point, and at A point it's 20 minus p opposite as compared to B point. Okay, just consider individual forces P1, P2, P3 on the basis of this calculation. 30 kilonewton tensile positive, 20 kilonewton again tensile positive, and this 20 minus P force is tensile, okay, positive. L1, L2, L3 as per the section. We have considered CD as the first section 300, BC second section 400, and AB third section 500. To find total elongation, P1 L1 plus P2 L2 plus P3 L3 equals to 0. Just put all the values where P1 is 30 positive and L1 is 300. Similarly, P2, L2, P3 and L3. Okay, put all values and just solve this equation. We will get P force. Okay, 30, 500 P. So P force is 50 kilonewton, and our numerical is what we need to calculate. Determine the force P to be applied at B point. Okay, so we have calculated that P force. Okay, the P force is equals to 54 kilo Newton. Okay, now this we will discuss in next video. That is, this is actually third type of numerical elongation of varying cross section bars with the intermediate axial force. Okay, so we will, I request everyone, please, if you are uh, satisfied with this teaching, please like, subscribe and share this video to your friends, so they will get benefits from this numerical. And please uh, share your comments or share your suggestions in the comment box. Thank you.